All right, good morning, everyone. As Andrea said, my name's Martin Dixon. Let's get this forward a little bit. My role at Google is to run our data center performance for systems and make sure that all of our systems, all of our heterogeneous systems, perform well. And that is inclusive of all sorts of different platforms. And today, I'd invite you to come with me on a road trip to talk about RISC-V at data center scale. So we can't talk about the road ahead without talking a little bit about what's behind us. Google just celebrated its 27th birthday a couple weeks ago. We started as a company that was on commodity compute. And commodity compute at the time meant x86 platforms. If you've looked at my background, you might know I know one or two things about x86. In the mid-teens, some interesting things happened, and there's some likenesses to what's going on with RISC-V at the moment. Arm published their server platform specification in 2014. And about a year later, we started to dip our toes into RISC architectures in the data center fleet. Flash forward a few years to 2022, and we released our first instances of the Tau T2A Arm servers. And just last year, we released Axion, our latest Arm server. And I know I'm talking a lot about Arm at a RISC-V summit, but there's a reason here. But every road trip, the road trip that we're going on, begins with a destination in mind, right? And that destination is warehouse scale computing. Our data centers today include components that have instruction sets from x86, ARM, and RISC-V, as well as others. We believe that heterogeneity and specialization are the key to addressing the slowing of Moore's law, and that this is the path forward to greater warehouse scale compute. RISC-V has this fantastic differentiation, openness to it, and customization, but it can be a little bit of a double-edged sword. And so we need to make sure that we have some subset standards like RVA23 that Andrea was talking about earlier, the server platform specification that are coming in, to make sure that we can have a common baseline for our destination of warehouse scale and RISC-V. So every road trip needs a few ingredients. You need a roadmap. You need to know where you're going. That's that server platform specification. Certain features are mandatory when you are at scale. You need something like Intel's LBRs, ARM's BRBE, or the CTR spec that's coming along from RISC-V. Now, almost every single binary that we run has gone through some sort of feedback-directed optimization loop. And so we need all of the information in order to tune our binaries. Crypto needs to be side-channel hardened. You need an IOMMU to protect against DMA attacks. We are providing some feedback into the server specification, and we are looking forward to that being ratified and moving forward. You need a cool car. I mean, you can take a road trip in a boring car, but you need a server class SoC with at least 64 cores and the ability to provision for 4 gig of memory or more per core. And then it needs to have the right features, and the features include performance. Survivability, maintainability, things like that. You need to have Beyonce. And there's one thing that you guys are going to remember about me talking up on stage today is that the Google guy, whose name you don't remember, was up there talking about Beyonce. To paraphrase Hunter S. Thompson very badly, a car that's got its gas needle on empty can go 50 more miles if you've got the right music going at very, very loud volume on the radio. The Sweet community appropriated a lyric from the song All the Single Ladies by Beyonce that's, if you liked it, then you should have put a ring on it, and instead, you should have put a test on it. We found this to be incredibly true. If there's functionality that you depend upon for your software, it needs to have a test. It makes multi-arc porting much, much easier. And then, of course, none of this can happen without friends, right? It's this community and the community beyond, making sure that we have all of the software we need so that it pretty much compiles and runs out of the box. So let's talk a little bit about our learnings on this road that we've been on from x86 to ARM. sys to RISC. This graph shows it's an abstract unit of compute, but this is Google's top 100 workloads for internal. There's a whole bunch of names that you know in here, like you might have heard of YouTube. Things like that, Spanner, BigQuery, Bigtable, they are some of these big workloads here. And this top 100, or top 50 rather, only represents about, it's actually close to half of our compute these days, but we published 60% a while ago. Obviously not a uniform distribution, and the thing is you'd think that, oh, I can just port the big workloads. Well, I can't. I can port the big workloads, that's great, but I also need to, like I'm packing the trunk of my car when I'm going on a road trip, fill in some little workloads, because that's how scheduling works at data center scale. The scheduling agent needs to pack in big and small jobs together, so it's not good enough to just go after the top workloads. So for these different users that we have, we needed to go for different approaches. Honestly, most of the workloads that you saw on the last page, they're the big users. The amount of compute they're using is a lot. These big users we targeted with central porting and bespoke pilots, making sure that we could make sure their service is safe. The path to scale, which is where we're on at the moment, we've had something like 30,000 plus packages that we've already ported, made multi-arc capable. This is automation. A lot of framework works. We use frameworks for running lots of server packages. AI-generated changes that we'll talk a little bit more about. And then there's a long tail, that the next 50,000 workloads. And all of those, we need self-service. We can't have some SWE go and talk to another SWE to do it. It's just not worth it. AI recommendations for this is how you should port your code and make it safe to run on other platforms. All of this, of course, requires excellent documentation. So we started our journey with a little bit of a road test. Using our CI/CD platform, we basically built things without the developers knowing. Assuming it passed all of the tests, again, back to Beyonce, all of those tests, we would push a pull request, or CL in our parlance, for the developer to say, hey, if you just do these 3-line change to your build file, lo and behold, you will be able to run on another platform. And for the developers and for Google, ARM's not new, but it is different. Obviously, the instructions are different. Memory ordering is relaxed. Big Indianness is theoretically an option. None of this matters. It really doesn't. The tools already make it work. What most developers care about and what they stressed about was, does my service run safely on this other platform? They worried a little bit about performance. They don't want to get support tickets to, hey, your service is running slow. They're worried about data corruption. But in general, they want to focus on new features. So there was a little bit of fear in there, but in general, it went quite smoothly. And this quote from a tech lead in our ads organization pretty much sums up our journey to ARM, and I think will sum up our journey to RISC-V. Everyone totally fixated on the tool chain, everything's going to break, and the reality was it was boring stuff. It was config files, build files. It was changing paths that were x86 64 into AARC 64, things like that. It wasn't hard stuff. We did encounter a few potholes on the road. Flaky and overly specific tests. Timeouts. They had a very tight time bound on a test. There was an if-def x86 64. There was an else for AARC 64, and the two code paths were divergent. Little things like that that really aren't, they're not hard, but they did need to be addressed. Floating points. x87 supports 80-bit precision floating point. There are some differences between platforms. We just converted everything to float 128 if it was extended, and took care of it that way. Little other bits and pieces like NAND numbers, NANDs, are encoded slightly differently between different platforms. And so if you're doing bitwise comparisons, oops, they're not the same thing. Comparing NANDs doesn't make logical sense, but people puts them into a block, and then they do CRCs in that block, and lo and behold, they get different answers. We did encounter a few memory ordering issues. But you could count them on one hand, and honestly, they would have occurred on x86's TSO model. But they were so unlikely that basically it was background noise. So again, I think we counted 3. In fact, we were having a little bit of a competition to figure out if we could count the number that we had. And then the boring stuff, right? Lots and lots of those config files and the changes there. So we believe, again, that it's the friends that come along for the ride here, that ecosystem collaboration is the best way for us to be able to smooth the road out. And with RISC-V International, we're collaborating on the key server standards, like quality of service, another important standard for us. RVA 23, again, very happy to see Andrea's note earlier about that and how that is being adopted. And as a founding member of RISE, we're accelerating the software stack by working upstream on Linux, on LLVM, and other packages. So as you're rolling down the road, listening to Beyonce, you want to sit back, relax, and click on the cruise control a little bit. We started this journey with a little bit of automation. We had tests, safety. So maybe we had automated braking in the parlance of autonomous vehicles here. At the moment, we're kind of at a stage where we have automation AI that help with code edits, rollouts, as well as, of course, testing. We'd love to get to a place where the machine is handling all of the work associated with porting to a new instruction set. So I'll talk a little bit about how we applied AI to our manual porting effort to scale it up. We had something like 40,000 different code edits that were associated with ARM. We fed those into Gemini. It categorized them for us into 4 different big buckets. There's actually 17 smaller subcategories. This is things like code adaptation that I mentioned earlier, test configuration or overly tight test bounds, build and config files, adding in ARC64 in places where it was missing, and then some supporting work. This might be something like a dashboard that needs to know that, lo and behold, there's a different architecture flavor or something else going on there. But the coding part's only part of the journey, right? You can build it, it's great, but you need to deploy it as well. So we have an agent that goes in and assesses jobs on multiple different architectures to determine whether or not they are executing properly. It follows SRE production principles. So basically you go 1%, then you do 4%, make sure it's safe to run across data center scale before you ramp up. And it automates rollouts to the point that most teams don't even notice that it happens, especially the teams that don't have an SRE team associated with them. We had a couple groups, a couple developers that panicked when they found out that they had been serving live traffic for the last month or 2 off of a different platform, and they didn't even know it. This is what we're aiming for. We're aiming for this to be seamless and to roll out. Something I forgot to say on the last slide as I was moving quickly is my colleague Martin Moss from Google DeepMind will be doing a much deeper dive into the AI applications and how we applied them to our journey here. That's on the developer track later today. And we also released a paper on arXiv on Friday, a preprint of that, as well as a blog entry yesterday to talk about our journey here. Great, so talked a lot about ARM. Let's talk about the road ahead for RISC-V. We need these ingredients, right? We need to ratify that server platform specification, the roadmap. We're providing feedback. We're one voice in the community. We're very much looking forward to that standardization there. We need the car. We need the SoC, right? We need a server class platform that's got at least 64 cores, if not more, and has provisioning for 4 gig of memory per core around, and a few other bits and pieces with the right performance. We need Beyonce, again, only thing you'll remember. Increasing test coverage. Make sure that you have tests on functionality that you need. Embrace AI and autopilot. We will be announcing with RISE and RISC-V International's guidance, 5 academics that got $50,000 worth of Gemini credit in the next few weeks. And then, again, to kind of butcher a different quote from Jack Kerouac, let's lean forward to the next venture here on RISC-V and at warehouse scale. So with that, thank you. Enjoy the rest of your conference. I appreciate you spending the time with me today.